Welcome back. So in this section, we want to talk about securing cross-chain communication. And first, let's cover some cryptographic basics. So Aaron, can you tell us a little bit about signature schemes and kind of like what we want to achieve by using signature schemes?
Sure. So signature schemes provide us a primitive where we can have some party that generates a signature over some message. So let's say me using some private key that I would generate randomly. And I can send you that signature and the message, or you could already have the message. And you can take that signature and verify that I, the owner of that private key, actually did sign it. So there's a couple of properties here that are important for signature schemes that you've so nicely listed out that I do not know off the top of my head, but can run through. And so those properties are authenticity. So you can actually verify that I, not necessarily I, but the owner of the private key actually did sign the message. And that's called authenticity. You have non-repudiation, which is the fact that I can never in the future deny that that private key was used. So there's no way to say, oh, no, that was not actually me, or that was not actually the owner of that private key. That signature lasts forever and is always valid to be verified. And then actually, could you remind me of what the third was?
Integrity. So someone
Integrity, that's right.
delivers that
Go
message can't change anything about the message, right? Like, so even if you sign the message, I'm the delivery person. There's no way for me to, like change a number or a paragraph or whatever is part of the message without the receiver being able to notice.
Yep.
Yeah. So for signature schemes in practice, like if we develop with signature schemes, we have three functions: generate, keys, sign, and verify. Right, and that really hooks into what you just said. Maybe you want to talk a little bit about like how we use these functions.
Sure. Yeah. Where we might use these functions is I would generate a private key. After I generate that private key, I might want to, or you might want to send me a message, and you might want to have some proof to another party that I in fact signed that message. So you could send me some message M, and that message M could be Martin is the best. And so I can take my private key and I can sign that message, Martin is the best. And you can always, from there, I can send you your signature back. And from then on, you can prove that the owner of that private key signed the message, Martin is the best. Therefore, that person signed, verified, and decided that it was in fact true, Martin is the best.
Awesome. Cool. So yeah, as we can see already, we want to use these signatures to attach them to messages to get these properties that signature schemes offer. So when we talk about cross-chain communication, like most of the time, it's probably not sufficient to have a single party attest that something happened on the source chain, right? Like we want to have large parties. So there are like signature schemes that actually specialize on this. We call them multi-signature schemes. So what would you say? Like when we think about, like a single message, maybe it has 64 bytes. We have like one signature of, like 69 bytes, 96 bytes. What's the problem there if we have like a large validator set?
So the problem there, if you have a large validator set, would be that with a lot of different signature schemes, if you want to validate that 1,000 people all signed this message that Martin is the best, then you might have to validate 1,000 signatures. And at that point, we take this process that previously, when it was just validating one signature, only took a constant amount of time. So now it's going to be O of N in the total number of people that you want to validate. So one alternative to this is that you can have these multi-signature schemes. And what these multi-signature schemes do is they allow you to have a more efficient format by which you can validate a signature from a large number of parties. So take, for example, a situation where you have 1,000 parties, all of which have their own private key and their own associated public key. You could have pre-computed the aggregated public key of all of those different corresponding public keys. And so what you can then do is me and the other 1,000 people that you want to verify from, we can all independently produce a signature. And one of us, any of us, can aggregate all of those signatures down into one compressed multi-signature. And now if we send you that signature, you only have to receive this one compressed multi-signature instead of 1,000. And you can perform that same process to verify a single signature as opposed to verifying a much larger number of them.
Awesome. Cool. Yeah, in this course, we also have a little demo about this where you can play around with, like aggregating signatures, but also just the basics of signature schemes. So definitely check that out. And thank you very much, Aaron. I will see you in the next lesson.
Thanks.